Hello everybody, and welcome back to my channel. We're going to do another kit build today. Yes, it's another Christmas tree. Cue vitriol in the comments about it not being Halloween yet. They don't have any Halloween-themed kits in my local electronics store, and this one is actually pretty cool. So the reason why we're doing another kit build, in fact we're going to do two kit builds over the next couple of videos here, is because I've finally worked out some of the kinks with the crappy lighting bars that I got from Banggood, and I've developed a good circuit to run them, and I've even built a nifty prototype, and I'll be going into how to make these, and I'll be installing them in my workbench, and my lighting situation should finally be quite nearly ideal. But those little lighting modules that I just showed you take a great deal of time to build, and so I'm going to build most of them ahead of time, and then I'm going to do the rest on camera. I'll probably only do one on camera because it's quite an involved process. But I want some practice on how I've got the discrete soldering done and everything, so it goes all nice and smoothly. So, what we have here is another Christmas tree project. And this one, instead of using capacitors, well, it's kind of along the same line as the previous circuit, where it uses what's called an astable multivibrator. And what that basically means is a circuit that turns itself on and off and on and off and on and off and never stops. A stable multivibrator will go on, off, or just on and then stay on, whereas an astable multivibrator never reaches a stable state. And the way that works, if you have a look at the I need something to point with. I will use a toothpick. That'll work. I'll use a slightly cleaner one. So the tree is actually comprised of two different circuits on each of the boards here. And each of those boards has an astable multivibrator with these little NPN transistors. Now, what happens is this capacitor begins to charge off of this resistor. When it reaches about 0.1 to 0.2 volts, the base of this transistor turns on, and the gate inside the transistor opens and these LEDs illuminate. Then, being as that side of the circuit is now open, this capacitor starts to charge. And when this capacitor reaches about 0.2 volts, this transistor opens up and current begins to flow over on this side. And by that time, this side, this capacitor is basically discharged. The base goes low again, and this side of the circuit shuts off again. And the current just switches back and forth between those two sets of LEDs, and the same way with this. On this one it'll seem a little bit more random because you've got a 100K resistor and an 82K resistor, so they're going to charge at different rates, which means that the blink rates are going to be different. But that's how you set up a basic astable transistor multivibrator there. They also call them free-running multivibrators as well when they don't shut off. So this is going to be a fairly standard soldering project, except for the fact that in this case it is a 3D tree. So we're going to solder most of the components onto the board, and then we put it together like that. And then we have a little tree that stands up. So that should be actually kind of cool. So let's start with, let's see, which one does it want us to start with? It wants us to start with the one that has the battery terminal. So we'll just put this one off to the side. And the picture on the front of the box has it done with all red LEDs, but they threw in a couple of green and yellow LEDs, so we'll incorporate those into the circuit a little bit, just for fun. I haven't quite figured out how I'll do it. I think I'll put reds on the top, alternate the greens and yellows, and then reds on the bottom. Just because, for whatever reason, the number of LEDs is divisible by 4, but I only have 3 colors. So, this is a fairly normal soldering project, except for a couple of elements. The first being these little springs. Now these are going to be a fair bit challenging to do here. So what we have to do is kind of stretch, oops, and the throwing it on the table or pinging it across the room, it's a very important step as well. You mustn't forget the part where you drop it and ping it across the room. So we have to run it through that hole, and then, because the spring doesn't quite reach all the way across, it looks, we'll grab a pair of pliers here. We'll just grab that spring with the pliers and pull it over into the hole. I don't want to push it too far through the hole because I don't want to have a nasty edge, so we're just going to kind of level that out. Oh, did I push it all the way back? I didn't. Okay. So we just want to make that kind of level with the board there. I'm going to turn on my soldering iron too, because that's an important step as well. Then we'll grab the other one and do the exact same thing with it, and just push it through. Oh. Come on, get in there. There we go. And then the same thing, we're just gonna grab that, come on, grab that wire with the pliers and push it in. There we go. And we'll just kind of give it a gentle tap there to make sure that it doesn't stick out and stab anybody, because those are actually kind of sharp. So there we have the battery terminal springs installed. It's actually kind of neat because once it's fully assembled, it actually sits on top of the battery, and the battery sort of becomes the trunk of the tree. At least that's the way I believe they mean for it to work. Now we're not gonna use a lot of flux on this project. I'm hoping we can avoid using too much of this. But in the case of the battery terminals, because those springs are going to take all of that heat and radiate it out, because they're just sitting there being tiny radiators, I want to make sure that I have plenty of thermal mass going on there. So we'll just tin tip here. I haven't used this soldering iron in a while, so I'm going to give it a little bit of a clean with this goo that I have here. And then scrub it off in my brand new scrubby bit there. Still got some carbon on the tip here. Let me see if I can scrape some of that off. It's important to maintain your soldering tips. This one's going to need a little bit more care, but I'll do that off camera. Where's my slack? There we go. So let's just quickly, this is exactly what I was worried about here. There we go. There we go. And there we go. We got a nice bead of solder holding those terminals on now. As you can see, the big ground plates here, these are going to make soldering some of these quite a pain in the butt. So the next step is to identify which resistors are which. Now it says R1 to R4, and we've got R1, R2, I guess R3 and R4 are going to be over here, yeah, R3, R4. So R1 through R4 are going to be 1 k ohm resistors. So if you remember from our resistor color code, we need the 1 digit, which is going to be brown, and then a 0 digit, which is going to be black, and then we need to make enough zeros after that to make it 1000, so we're going to need 2 zeros. So we're going to need brown, black, red for the color code. And those brown, black, reds happen to be right here. I don't know if the camera's going to show the color stripes too well, but this brown, black, and red. So we're going to grab 2 of those and pull them off just like this and just like that. And we're going to bend the leads down like so. And then again, don't have to be too super exact with these. And then we're going to find our R1 position. Just drop the lead in there. Oops, and drop it right back out. Another, again, very important step, dropping the resistor out of the board. You know, just because everybody's got to look a little silly while they're working on these. There we go. Alright, and now time for the soldering technique wherein I do something that requires 3 hands with 2 hands. So we're just going to grab the soldering iron here. And draw some solder onto that. Oop, come on. There you go. Ow! Ooh, I got a little toasty. So now that we've got the... Ow! Good lord, that is quite warm when that does that. Now what I'm trying to do here is... There we go, get the component nice and centered. But because the tracks on this particular project are so big, I'm having a bit of a challenge getting a nice solder joint going here. Gonna have little scorch marks all over the board from my attempts. I might actually have to start using more of the flux, which I was kind of reluctant to do, but alrighty, so we're just going to put R2 on now. That one's actually, no, it's not going to hold itself in. But you know what? I'm just going to do that and seat it in a moment. So, get that. The solder is just not flowing onto this resistor. And there's some sort of coating, there we go. There's some sort of coating on the board here that's burning off and releasing a kind of unpleasant aroma. Ow. I'm sure this is all very exciting, watching me burn myself repeatedly trying to get these resistors to solder nicely. Come on. There we go. There we go. And this one's going to be a pain because it's got a huge pad on it. There we go. But thankfully, this big fat soldering iron tip does help a little bit with those pads that have a large thermal mass. That's what the term for that is when you have big pads that suck up all the heat. Anyway, so the next step is going to be, I guess we'll do R5 and R7. Now those are going to be two different value resistors. You'll remember earlier here I was talking about the 82 and 100 k ohm resistors that provide the slightly different blink rates. So for the 82k resistor, we're going to need a violet, no, violet is 7. Green. So to make 82K, we're going to need green, red, and then 3 zeros, so orange. Green, red, and orange. Or sorry, gray, red, and orange. Green is earlier in the thing. So here we go. We've got our gray, red, orange. So that's our 82K ohm resistor. And that's going to go into the R5. I believe it's the R5 position on this board. Yeah, that's going to go in R5. So we'll just slide that in there. Lament the fact that there are still giant solder pads on this. So we're just going to touch that there. Oop. Oh, that's still a bit of a cold joint. Come on. There we go. And then, ooh, that's toasty one. All of the solder just stopped flowing on that pad. Well, this is going to be a difficult project. I may have to give in and start using more flux. I'm really reluctant to do that though, because it leaves sticky stuff all over the board, and I don't want to have to be cleaning sticky stuff. I don't have flux cleaner, so I'll have to go out and buy flux cleaner before I really display this. But we'll see what happens as I continue. So the next resistor is going to be R7, and in this case R7 is a 100K ohm resistor. So brown for 1, black for 0, those are our first 2 digits, and then to make 100K we are going to need 4 more zeros, and 4 is yellow, so we need brown, black, yellow. And here is our brown, black, yellow. I can't even see the yellow stripe, it doesn't even show on that sort of beige-ish resistor there, but that's brown, black, yellow. I don't know if you guys can even see the resistors, or the color bands on the resistor, so I'll have to see when I edit the video. Anyway, so we're just going to take that, we're going to flop those leads down, and we're going to take that and drop it into the R7 position right there. Oh, nice, that's going to kind of hold itself on, which is nice. And then put a little solder on the iron there. Oh, that worked much better, pre-wetting the soldering iron. So we'll just flow that. I didn't bother centering that resistor because it kind of did it itself kind of nicely there, so there's that one. Alright, the next step are the capacitors. Now, we have these 4 electrolytic capacitors. They are polarized, so you have to make sure you pay attention to the stripe on the can here, which is the negative side of the capacitor. And it's saying that we need 10 microfarad capacitors. Now these are all 10 microfarads, but reading the value of an electrolytic is very easy because it's just written on the side. It says 10 microfarads, so that's 10 microfarads. So that's going to go into C1 and C2. Now you'll see the spots here for those capacitors have a little plus marked on the breadboard. So we're going to take that and put the positive lead into the positive side there. Seat the capacitor down, and then we're going to solder it. So using that technique that I just discovered by accident, we're going to wet the tip of the soldering iron a little bit, set it down on the board. There we go. I think my cat has found a cockroach. I hate this apartment complex. And there we go. There's C1 set up on the board. And then we're going to come over and we're going to repeat the same process on C2. So putting the negative side of the can onto the negative side as marked on the board there. It's nice that the PC boards are all nice and clearly labeled here. And we'll the soldering iron. And I gotta monkey around a little bit here to get this one set up. There we go. And there we got it. So there are the capacitors set up on the board. Now, the next step are the two transistors that run this side of the board. Now, I'm a little disappointed. We don't have the ammo pack transistors. We've got the flat pack transistors, which I find a little... I prefer the ammo pack transistors because they are already spread into this three-point formation, whereas the flat pack transistors, surprisingly enough, are packed flat. There's no real ideal way to seat these, so I just kind of use friction to spread them open. And as a transistor is a heat-sensitive component, you actually want to make sure it stands a little proud off of the board so that while you're soldering it, especially on a board that is taking so much heat to get the solder to set, we're going to want to make sure that sets fairly proud on the board there. Just to make sure it doesn't interfere with anything, we're going to it actually shows the capacitors being laid flat. I wonder if that's going to be significant. I'm going to check that real quick. It shouldn't interfere with that side. That's just going to be leads on that side. And yeah, I don't think having... It looks like it wants them to lay down, but I'm not overly... this is itching. I'm not overly fond of that concept. Just because I don't want to have to desolder the capacitors with how difficult this board is being. So we're just going to leave those the way they are, and if I have to mess with them later, I will. And if anybody is wondering, this is a battle wound from when I was cutting the aluminum bar for mounting the lighting modules that I'll be working on in a later video. The hacksaw I was using decided it hungered for some human flesh, and so it bit me. And it bled quite a lot. I was rather surprised. I think perhaps there might have been some oil on the... Okay, I'm gonna flux this. There might have been some oil on the hacksaw teeth that was acting perhaps as an anticoagulant, because I bled through several Band-Aids, and I'm sure you guys are just totally interested in hearing about my wound, but there you have it. The inane chatter that I come up with as I'm trying to solder stuff. Okay, so there's that transistor set. We'll grab the other one and repeat the process here. Now on this one you'll see that the shape of the can of the transistor is marked on the board. Sometimes it'll be marked with ECB, emitter collector base, and you'll have to either know off the top of your head which is the emitter and the collector and the base, or look it up in order to mount the transistor properly. So because that first transistor was being difficult, I'm just going to dab a little bit of flux onto these pads. One of these days I will buy myself a flux pen so that I can stop using this really goopy, messy stuff. It's good for applications where you have to use a lot of flux all at once, but these kinds of applications, it's not so great. So there's the second transistor set. It's not quite as nice looking as I'd like, so just give that there we go. There's both transistors now mounted on the board. And now we just have to do the LEDs, I believe, are the last components on the board here. Yep. So, I'm just going to lay them out the way I'm going to mount them. So we're going to have 2 red LEDs, 2 yellow LEDs, 2 green LEDs, and then 2 more red LEDs. Oops, 2 more red LEDs. Now, the board actually has 2 different markings on it for demonstrating which of the leads goes where. On most LEDs, I'm not too sure if these little tiny LEDs have it. These little ones don't, but on the larger LED packages, do I have one maybe over here? I don't even know if I can show you guys. But on the larger LEDs, there's actually a flat section, and the flat part of the LED marks the cathode, which is the positive side, and the long wire is the anode, or the negative side of the LED. I think, unless I have that totally backwards. I'd feel really stupid if I just told those backwards. I even used to have a mnemonic as to which was the cathode and which was the anode. And I am pulling a complete blank and making a fool of myself in front of hundreds of people on YouTube. So I'm just going to look this up real quick to make sure I'm giving you the correct... Okay, the cathode is the negative side, which I believe I said backwards. So forget what I just said earlier. Ignore all of that. The flat side marks the cathode, which is the negative side. And I should have remembered that because I've always thought of the positive side as the long one. It's got plus wire. And the positive side is the anode. I always get cathode and anode mixed up in my head. Anyway, so let's throw that off to the side. So in this case, we have to go off of the, rather than the flat side of the LED, we have to decide which side of the LED is by which of the wires is longer. And in this case, the anode here is just a little bit longer, but it's long enough for us to identify which is the correct lead. So now these ones we do have to lay down flat in order for them to look reasonably decent. So I'm just going to kind of get an idea of where, yeah, that's actually pretty good there. So there's a spot, there's a spot on these LEDs where they've welded the leads onto, or the longer leads onto the short leads that were made in manufacturing of the actual LED. So we're just going to kind of stop it there and then bend it over. So as you can see, that's actually pretty much a perfect spot for it. So, and then because LEDs are also heat sensitive, not as much as transistors, but they still are fairly sensitive to heat. I'll dab a little bit of resin onto the pads here, and then we'll solder them on, just like so. Because these LEDs also have really big tracks on the board. I wonder why they did that. I wonder if it was a stylistic choice or if there's actually some logic to these great big tracks that they have on the board. But there we have it. There's one of the LEDs done. I'll just do one more regular speed, and then we're going to time-lapse the rest of this while I do the other side, because you guys probably don't want to watch me do both sides while trying to figure out what to talk about. So we'll just bend that over like so. That one's not holding itself in so much as well, so spread the leads out a little bit there. Let's try this one without resin. There we go. I'm going to have to readjust here. Ooh, toasty. Okay, there we go. And then I'll just solder that one on too. There we go. Alright, so that's a demonstration of all of the components as they need to be placed. I'm going to go ahead and go off into time-lapse mode to do the rest of these two boards, and then I will see you on the other side of that time-lapse with a completed circuit. So be back in a few minutes. Alright, and we're back. I realized, much to my dismay as I was continuing to build this, that I made a bit of a mistake with my arrangement of the LEDs. I thought I was being all clever with changing the color of the LEDs on these boards, but I hadn't considered that with the physical arrangement of the boards, that was going to put two colors next to each other on each side. So, well, I guess I'll just have to remember that if I build a second one of these, which I might, just for fun. So we're on to the second phase of the actual physical part of the construction here. We have to do something kind of a little weird. We're going to take these little jumper wires here, and we're going to run them through the circuit board here. This is going to actually be a little bit challenging. Oops. Ah, come back. Bear with me here. I probably should have played around with this a little bit beforehand, but there are two holes on the board here, one on one of the boards and one on the other board. And we have to thread this jumper wire through both of them. So bear with me a moment as I struggle with this. I'm definitely not having the best time with this. It is being very recalcitrant. There's a word for it. There's your word for the day, recalcitrant. There we go. So I'm just going to kind of brute force it. There we go. So then, I'm going to just quickly solder the one side of it here. Thankfully, this isn't actually an electrical connection. I don't believe, at least. It actually is an electrical connection. I hadn't thought about it, but that kind of makes sense. It provides the continuity between the two boards for the current flow. So we'll just quickly solder that on, and then I'll just take my snips here, snip that off right there, and snips that off right there. And then there's the second jumper wire. Just goes on at the top here. I'm gonna learn from the past. Take plenty of this out. Just be a little excess there. And do it like that. And then we'll repeat the process of soldering this jumper on. Maybe. Come on. Get on there. There we go. And then we're just going to put a little bit of tension on that wire just to get a little bit tighter. Kind of give it some structural integrity such as it is, and then solder that other wire, just like so. And then once again, we'll trim that nice and flush, trim that one. One of these days I hope to be able to afford a pair of Xuron flush cuts. I've seen those in action. They are absolutely amazing. Most flush cuts, when you snip a wire, they have sort of like this little pinched edge to them that's actually a little bit sharp, and you can catch yourself on it and get the sting a little bit. But the Xuron ones, because of the way the jaws are built, when you cut a wire, it makes a perfectly flat surface across the top of the wire. They're really amazing, but they're also quite very expensive, and they're made in America. So if anybody from Xuron happens to be watching this and wants to sponsor a video, I'm just kidding. I probably won't do sponsored videos. Anyway, so that's that. If I did everything correctly and got everything soldered without burning out a transistor by soldering it too long, that should be complete. Let's see, J2 to J2, J1 to J1, that's the important part. So we'll just drop this battery in, minding the polarity, and what do you know, it's flashing away rather happily and fairly randomly. It's not perfect, but looks pretty good. I'm just going to reach up here and kill the lights here. I guess I can just kill it by that. Now you can see the lights flashing away there. That's not perfect, it's just kind of an up and down and sort of not really greatly random, but hey, it works. And you just set it down there on top of a 9-volt battery and it flashes away rather happily. There is actually an option on this module where you can actually, these pads here that you see on the tip of the tree there, you can actually connect wires to that and then hang the tree and run it off of anywhere from a 9 to 12 volt power supply. It's got a little bit of regulation built into it, I guess. But there you have it. There is the second LED Christmas tree of this season. I will be building one more. It's actually a much fancier one, but it's on its way from China because that's where I ordered it from. That's actually much more sophisticated and more visually attractive and has some nicer appearance to it. And I've also got a little bit of a traffic light. It's called a traffic light kit that I'll be building for the next video, which will be hopefully released on Thursday. So thanks everybody for watching. If you enjoyed it, give it a like, share it, let your friends know, get them to subscribe. I hate to beg for subscribers, but I'm at least trying to get to 100 subscribers so that I can have a custom channel name. It would be awesome if I could get 100 subscribers by Christmas, but we'll have to see what happens there. Anyway, thanks for watching, and I will see you on the next video. Bye-bye.